Okay, so imagine this for a moment. Imagine a place so deep that if you dropped Mount Everest into it, the mountain would disappear completely and there would still be 2 kilometers left before reaching the bottom. A place where the pressure is so extreme that your body would compress to the size of an orange in less than a second. That place exists, and the most disturbing part is not how deep it is, it's what scientists are finding down there. Things that should not exist, life where life should be impossible, and systems that may be quietly controlling the stability of our entire planet. Number 6. The Mariana Trench, the impossible abyss. The Mariana Trench descends nearly 11 kilometers below sea level. At that depth, pressure exceeds 1,000 atmospheres. Steel bends, seals fail, electronics behave unpredictably. Only a handful of missions have ever reached the bottom. Each descent required years of preparation. Time at the sea floor is measured in hours, never days. Scientists expected to find simple bacteria. What they found instead changed everything. Complex organisms, amphipods the size of your hand, fish whose proteins fold correctly under pressures that should destroy molecular structure. Life adapting not just to survive, but to function. And then there's something even more unsettling. Beneath the ocean floor, layers of sediment millions of years old behave unpredictably. Geological models begin to fail at these depths. Some researchers suspect these trenches may be storing more carbon than the entire atmosphere. If that is true, our climate models are incomplete. But there's a problem. Penetrating those sediment layers risks destroying the very samples scientists need to understand them. The Mariana Trench is not just the deepest place on Earth. It may be a hidden regulator of global systems we barely comprehend. Number 5. The subglacial lakes of Antarctica, the hidden ocean. Now imagine a lake the size of Ontario, Canada, buried beneath 4 kilometers of solid ice, isolated from the surface for millions of years. No sunlight, no atmospheric oxygen, no connection to any known ecosystem. That lake exists. It is called Lake Vostok, and there are hundreds more beneath Antarctica. These lakes remain liquid because of geothermal heat rising from below and immense pressure above. Without sunlight, any life must rely on chemical energy, reactions between water and rock, radioactive decay, geochemical gradients. Scientists cannot directly sample these lakes without risking permanent contamination. Introducing surface microbes would destroy ecosystems that have been sealed since before humans existed. And yet, chemical signals have been detected, compounds that suggest biological activity in what should be sterile darkness. These lakes also influence how ice moves. Water reduces friction between ice and bedrock. Sudden shifts can trigger catastrophic glacial movement. The stability of Antarctica depends on processes occurring kilometers below the surface. Tiny modeling errors at that depth translate into massive uncertainty in sea level predictions. What happens in the dark does not stay in the dark. Number 4. The Mantle Transition Zone, the Phantom Ocean. Between 400 and 600 kilometers beneath your feet lies a region most people never hear about, the Mantle Transition Zone. Here, pressure forces minerals into entirely new crystal structures, and this is where things become almost unbelievable. These minerals can trap water within their crystal lattice, not liquid water, but molecules embedded inside solid rock. Some estimates suggest the total amount of water locked in this region could rival all the surface oceans combined. An ocean sealed inside stone. Seismic waves passing through this zone behave inconsistently. They change speed. They bend unexpectedly. Different interpretations of the same data produce contradictory models. Material movement here regulates how heat circulates inside the planet. Some materials stagnate for millions of years, others rise freely. These flows influence volcanoes and tectonic activity at the surface. But we cannot access this region directly. We infer its existence from vibrations traveling through the planet. The mantle transition zone may be one of Earth's most important regulators, and we have never seen it. Number 3. Ultra-deep cave networks, beyond human reach. Some of the most unknown environments on Earth are not in the ocean. They are beneath land. Massive cave systems descend kilometers underground, labyrinths extending far beyond mapped regions. These environments are unstable. Narrow passages, unpredictable flooding, rock collapses without warning. Gases like carbon dioxide and hydrogen sulfide accumulate in oxygen-poor chambers. Remote detection tools provide incomplete data. Large sections remain unexplored. And yet, life exists there. Ecosystems operating independently from the sun. Organisms relying entirely on chemical energy from minerals. Extremely slow metabolisms, minimal competition, extreme scarcity, stable environments. Some species have no surface equivalent. These caves also preserve climate records stretching back hundreds of thousands of years. But interpreting these records requires assumptions. Small errors distort entire reconstructions. Deep cave systems influence groundwater, ecosystems, and geological stability. What happens below can alter what happens above. Number 2. The deep biosphere, life inside rock. Far beneath the surface, life exists inside rock itself. The deep biosphere extends kilometers below continents. Microbial ecosystems occupy fractures and pores in solid rock. No sunlight, no abundant nutrients, almost no oxygen, and yet life persists. Some microbes divide only once every hundreds or even thousands of years, existing in a near-dormant state. Their energy comes from chemical reactions involving iron, sulfur, hydrogen, and radioactive decay. Most samples come from deep mines or industrial drilling. Data is fragmented, incomplete, difficult to unify. But evidence suggests this hidden biosphere may represent one of the largest reservoirs of life on Earth. It also plays a role in the long-term carbon cycle. Microbial activity affects how carbon is stored or released across geological timescales. Slow processes, invisible processes, processes that shape atmospheric composition over millions of years. Evolutionary pressures here are different. Minimal competition, extreme scarcity, stable environments. This biosphere exists beyond direct observation, and we are only beginning to understand it. Number 1. The Core-Mantle boundary, the planet's hidden instability. Nearly 3,000 kilometers beneath the surface lies the boundary between the mantle and the core. Temperatures exceed anything reproducible in laboratories. Pressures are beyond comprehension. This region is not uniform. Seismic data reveals irregular structures, fractured zones, materials unlike anything found at the surface. In certain areas, seismic waves slow dramatically, indicating partially molten material or unknown chemical compositions. These structures affect how heat escapes from the core, shaping convection patterns that drive volcanoes and tectonic plates. Heat transfer at this boundary sustains Earth's magnetic field. Variations in flow alter how molten iron moves within the outer core. Small changes at this depth can influence magnetic behavior at a planetary scale. The exact mechanisms remain uncertain. Chemical exchange between core and mantle may occur through localized plumes or slow diffusion. Evidence appears in volcanic rock signatures, but directly linking them to deep boundary activity remains a challenge. The core-mantle boundary functions as a dynamic interface, the deepest forces of Earth interacting silently.
And perhaps, within this invisible boundary, lies the key to why our planet is alive at all. You've reached this point, and now you know something most people never consider. Our planet is not what we think it is. Beneath our feet, beneath the oceans, beneath the ice, there exists a world we are only beginning to explore, where life thrives under impossible conditions, where scientific models fail, where every answer creates 10 new questions. Look at the pattern. The Mariana Trench, complex life under crushing pressure, subglacial lakes, isolated ecosystems for millions of years, the deep biosphere, microbes living inside solid rock. Life does not only exist where light reaches, it exists in the darkest, deepest, most impossible environments imaginable.